problem 3381, maximum subarray sum with length divisible by k. So for this problem, we are giving an array of integer nums, so inside it's going to be positive and negative integers, and as we can see from the example 2 and example 3. Yeah, so this means for this problem, maybe we cannot use the sliding window, because if we were to use the sliding window, maybe, yeah, according to the final return, yeah, we want to have always to be the positive value, but there's a negative numbers. Maybe we need to use another way, which is a prefix sum. So we're going to return the maximum sum of a non-empty subarray of nums such that the size of the subarray is divisible by k. Yeah, so we want to find such array, the divisible should be divisible by k. So for example, 1 is okay, so the subarray is 1, it is divisible by this 1, but the result is 1. 2 is also okay, but 1, 2, so the length is going to be 2. 2 divisible by 1, it is still 1, so it is okay. So it is the largest value, so it's going to be 3. Yeah. So this is a simple case. So let's check another case, maybe the third example. So let's just use the third example to try to find a way to solve the problem. Yeah. So for the third example, let's just use here. So for the third example, we have the numbers like -5, 1, 2, -3, and 4. Yeah. And then we can use prefix sum to get the prefix array to check what happens. Normally we're going to prepare a padding 0 because this is easy for the calculation. So we're going to have a 0, -5, and -4 because -5 plus 1 is -4, and then plus 2, -2, and then plus -3, -5, and then plus 4. So it's going to be -1. Yeah. So this is the prefix of sum with a padding 0. Now we want to calculate. So if k equals to 2, so this means for the first index. So for example, this is the index 0. We want to find the next index. So here it's going to be this index 2. Yeah, because from 0 to 2, we are using the prefix sum. So 2 minus 0, it is 2. So the final result is going to be -4. Yeah, because -4 minus 0, so the result is -4. But of course, it is not the maximum value. Yeah, but we can continue to check. So what about the next index? So it's going to be index 4. Yeah, because for this index 4, no matter if it is minus this index 2 or minus the index 0, it is always divisible by 2. So this is the even index. So at this position, this is -5. So for this -5, we want to minus a value. So whether we're going to minus a 0 or minus a -4. So for us, if we want to get the maximum value, normally we're going to minus the smallest value. So it's going to be this one, -4. Yeah, so this means the -4 is important for such case. So -5 minus -4, so it's going to be -1. Yeah, but this is not the biggest value. We still need to check the odd index. So what happens to the odd index? So for this first one, so this is a -5. So this is the index 1. And then we're going to use this index 3 here. Yeah, because this index 3 minus the index 1, it is a 2 divisible by k, it is a 0, it is okay. Yeah, so for this -2 minus -5, what happens? So it's going to be 3. 3 is going to be bigger than -1, so we're going to choose this 3. Yeah, but we are not finished yet. We still have the last one, so which is the -1. Yeah, which is at index 5. So at this position, we need to find a value. It can be index 3 or it can be index 1, but we want to find the minimum value, so it's going to be this one, -5. So this means -1 minus -5, it's going to be 4. 4 is bigger than 3, so 4 is going to be the final result. Yeah. So it seems this problem can be solved by using a prefix sum. And then we just need to record the minimum value of the mod. So for example, this k equal to 2, we need to record the minimum value for the modular result 0 and 1. So for this 0, as our calculation, so if it is 0, this is a -4, and this is a -5. Yeah, so before it is a -5, and then the minimum value gonna be this. Before it is a -4, and then the minimum value gonna be -5. Yeah. So this is the tracking of the 0. So what about the modular result gonna be 1? Yeah. So before for this one up to here, this is a -5, and then we're gonna compare with this -2. So the minimum value gonna be -5, and the last one it's still gonna be -5. Let me just check. Yes, it is. Yeah, because we are tracking the prefix sum. Yeah, so for this 0, for this modular result 0, before it is 0, and then we find the minimum, it's going to be -4, and then -5. So for this one, it is -5, compared with others, it is -5. So for example, if we find another value, maybe the next value, the prefix sum, I don't know here what about this number, but here, if the prefix sum is like 10, so what's going to happen, this is index 6, so this is the even index. So we're going to use this 6 minus this -5, it's going to be 11. So this is going to be the maximum result. Yeah, so this 11 going to be the result. So we always want to find the minimum value. So for the even index, the minimum value going to be this -5. So this 10 going to minus this -5. Yeah. Now let's just use this kind of method to finish the coding. So we're going to use the prefix sum to calculate the prefix sum for the numbers, and we're going to use the list accumulate with nums, and we're going to prepare initial to be 0. Now we need to prepare minimum sum array. So I'm going to use a minimum sum. Yeah, minimum sum array. So this minimum sum array going to be the infinity times this k, because the final result is going to be modular k. So for example, if k equal to 2, it's going to always be 0 and 1. So if k equal to 3, so the modular value is going to be 0, 1, and 2. So we don't need to prepare so many. So it's going to be infinity times k. Yeah, now we can check the final result. So for j and sum as in enumerate this prefix sum array. So for here, we can find the minimum position. So it's going to be this I equals to j modular this k. So we need to find the position. So this position is going to be inside this minimum sum array. And next, let's just prepare a final result. It's going to be negative infinity, because we want to calculate the maximum value. So here, this result is going to be the maximum with the current result, and then we're going to use this value's current value, this s, minus the minimum value, which is inside the minimum sum array, and the position going to be this I. And finally, we need to update this minimum sum array. So at position I, it's going to be the minimum of the minimum sum at position I, with the current value, which is s. S is the current value for the inside the prefix sum array. So finally, we just need to return this result. So this kind of calculation is exactly like what we calculated before for this example 3. Now let me just run it to have a check. As you can see, it works. Now let me submit it to check if it can pass. Yeah, as you can see, it passed all testing cases, and it's pretty fast. And the time complexity is just O(n), n is the length of the nums array. Yeah, because this value is dependent on length of the array and with the value of the k. Let's just check k, because this is dependent on k. So k is 10 to the power 5, and the length of the array is also 10 to the power 5. So the final time complexity is going to be just O(n). Thank you for watching. See you next time.